So 5 ways, one of them, you're going to see that it starts off listing only 4, but we're going to talk about 5 ways that things are a parallelogram. Okay, so before we even get into the first one, let's remember that the definition of a parallelogram says that this is a quadrilateral with 2 sets of opposite sides that are parallel. Now, that's not what this slide says, but the definition of a parallelogram says if it's a quadrilateral and it has 2 pairs of parallel sides, then it must be a parallelogram. And now, so that's like kind of our definition. Our definition is the first way we recognize it. The second way is right here. If both pairs, they have to be both pairs of opposite sides of a quadrilateral are congruent. Notice these. Just like we already knew, we said if it's a parallelogram, then both pairs of opposite sides will be congruent. If you notice that this is a quadrilateral and both pairs of opposite sides are congruent, then this will be a parallelogram. And as soon as you identify it as a parallelogram, then all the things that you know become true. This becomes congruent to that. This becomes congruent to that. We know that this is parallel to that. We know that this one is parallel to that one. We know that the consecutive angles are supplementary. We know that the diagonals bisect each other just from seeing those marks right there. The third way, because the first way is the definition, remember, the third way is if both pairs of opposite angles are congruent, then it's a parallelogram. So if I see this, there's 1 pair, there's 2 pairs. If they are both congruent, then I know this is definitely a parallelogram, which allows me to do all these things. I go up, this must be congruent to that, this must be congruent to that, this must be parallel to that, this must be parallel to this one over here, the diagonals must bisect each other, the consecutive angles must be supplementary. All of those things I know just from seeing that the opposite angles are congruent. If I'm going too fast, just stop me or tell me to go back. Okay, here's the one where we have a situation where it's 1 pair. If 1 pair, not both pairs, if 1 pair of opposite sides of a quadrilateral are congruent and parallel, they have to be congruent and parallel. So that means that these sides are the exact same length. Here's one set of sides, bless you, that are both congruent and parallel. If that is true, then it is definitely a parallelogram, meaning that these sides must be congruent to each other. These sides must be parallel to each other. These opposite angles must be congruent to each other. These opposite angles must be congruent to each other. The diagonals must bisect each other, and the consecutive angles must be supplementary. All those things we know to be true because we only had 1 pair of opposite sides that were congruent and parallel. So just that identification process opens up a lot of doors to us. It's like, is this a parallelogram? How do I know? Okay, if the diagonals of a quadrilateral bisect each other. Notice here I can see that both diagonals are cutting each other equally in half. It doesn't mean that all of these 4 segments are the same length. It does not mean that. It means that each line is being bisected into 2 congruent pieces. BD, the one that goes from the upper left to the lower right, has been split into 2 congruent pieces, and AC, from the lower left to the upper right, has also been split into 2 congruent pieces. So that is enough to say it's a parallelogram. Then we can go through all those steps again. I go, oh, well, this and this must be congruent then, and this must be congruent then, and then this angle must be congruent to that angle, and this one to that angle, and the consecutive angles must be supplementary. So you're seeing I know all those things just from being able to identify it as a parallelogram. Okay, so here are the 5 ways. This is all of them together. This is just everything that we just did. The first one is the definition. This is the definition of a parallelogram, is that both pairs of opposite sides are parallel. That is one way that you can prove that a quadrilateral is a parallelogram. First of all, it has to be a quadrilateral because it has to have 4 sides. And if it has 4 sides, and then you go, well, is it a parallelogram? Well, the first thing is, well, can you show me that both pairs of opposite sides are parallel? Now, it doesn't have to be directly shown. For example, I might have something like this. This right there is enough to show me that both pairs of opposite sides are parallel. How did I know that from this, that both pairs of opposite sides are parallel? Gio, this is like your specialty here. You gave it to me like a million times this one yesterday.
Oh, because of alternate interior.
Good. Notice that you have an angle. Let me color code this. You have an angle here that is congruent to an angle here. That means that these two must be parallel because of alternate interior angles. And this one here is congruent to this one here, which must mean that these two, top and bottom, are also parallel. I have two pairs of opposite sides that are parallel. Now you might be like, wait, but you didn't show me they were parallel. Right, but I knew that the angles, the alternate interior angles were congruent, which proved that the opposite sides were parallel, which proved to me that this was in fact a parallelogram. Yes, sir?
Wait, I have a question. Out of this, can't you also get like, okay, so like, I'm looking at like right now the triangle on the top, right?
The top right or the top?
No, like the triangle, like.
This one here, yes?
Yeah.
Okay.
So when looking at that, like, you know how we know that angle?
Uh-huh.
Like, wouldn't you be able to say that the bottom angle of that triangle is the same as that because of same side interior angles, or no?
The same as, you're saying that this one here?
Yeah.
This one would be the same as this one because of vertical angles. But that's not going to help me prove that it's a parallelogram.
No, I know.
Same side interior angles would be like this whole angle here. I'm just doing it big so it doesn't confuse with the other one. And this whole angle right there. Those would be same side interior angles.
Okay.
Just as the top right one and the bottom right one would be same side interior angles. Those corners are the ones that we're looking for that. So then our next way, the second of the 5 ways, is you can show that both pairs of opposite sides are congruent. That's like the first slide that we saw. Both pairs, opposite sides are congruent. Has to be both. Then we found out that we could also do it with one pair of sides that are both parallel and congruent. They have to be both. It can't just be one. You can't have one parallel sides. That won't do it. A trapezoid has one pair of parallel sides for those of you who are in other apps right now or in Safari looking at other windows. It can't just be one. You have to meet all these conditions there. Number 4, you can show that both pairs of opposite angles are congruent. Those are the ones that are in opposite corners. If both pairs of opposite angles are congruent, then it's a parallelogram, and you can infer all those things that you know about parallelograms. This must be true, and that must be true. Or number 5, you could show that the diagonals bisect each other. If the diagonals bisect each other, then it's definitely a parallelogram. So it's got to be a quadrilateral, but if it's a quadrilateral and the diagonals bisect each other, then it's a parallelogram, and then you can know all those things about parallelograms. All of those things get added onto there. Right, exact slide just shows you that thing. Both pairs of opposite sides are parallel. Notice that was the definition. Then we've got the other 5. Both pairs of opposite sides are congruent. That's what this would look like. Both pairs of opposite angles are congruent. That's what this would look like. One pair of opposite sides are congruent and parallel. That's what this would look like. Notice that the triangles mean parallel. Those lines mean congruent. Show that the diagonals bisect each other. That's what the last one looks like there. And finally, last but not least, we are going to do some solving here. So we've got those 5 reasons. So we're going to identify, it says state the principal definition or theorem that enables you to deduce from the given info that the quadrilateral is a parallelogram. So what we're saying there is given this information that BE is equal to ED and CE is equal to EA, which of those 5 things does that match? Yes, sir.
That the diagonals bisect each other?
Right. We see that the diagonals are bisecting each other. This is a quadrilateral. Then this is definitely a parallelogram. Guaranteed it's a parallelogram. So all those things about parallelograms are true about this shape. Yes, sir?
If I saw that in proof, what would I write?
If what?
The reason.
You would write it out in words. Yeah, you could just write it out in words.
Right.
Diagonals bisect each other?
You could say that the diagonals bisect each other, therefore this is a parallelogram. Okay, so I'm going to erase those markings on there because each one of these is an individual situation. The second one says angle BAD, which is here, is equal to or congruent to DCB, which is here. And angle ADC, ADC is here, is congruent to angle CBA here. Which one of those five reasons, somebody different? I love you, Gio, but I'm going to pick on somebody else so they can throw in two. Marcelo, what do you got?
If both pairs of opposite angles are congruent, then the quadrilateral is a parallel.
Good. Notice both pairs of opposite angles are congruent. Then this is a parallelogram. We've met that definition. So both pairs of opposite angles. That's the one that you're going to want to write there. I'm not writing it all out, but those are the ones you're going to want to write there. Both pairs of opposite angles are congruent. Therefore, this is a parallelogram. And then I'm going to move on to 3. BC up here is parallel to AD down here. AB right here is parallel to DC right there. Somebody different. Nathaniel.
Definition of parallelogram.
That's the definition of a parallelogram, which says what?
Opposite sides are parallel.
Yeah, both pairs of opposite sides are parallel. So that's what number 3 is right there. Finally, we go on, fourth, we go on to BC is congruent to AD and AB is congruent to DC. Somebody other than my 3 gentlemen who have already spoken. Somebody else. Amalia, how are you? No? Yeah, all you have to do is go to those 5 reasons we've got and see what does that match. Which one of those 5? You can even go back a slide and compare it to one of those. We just drew something in. What does that match? Hannah, you want it?
Yeah, like the opposite sides are congruent, so that's why it's like.
Both pairs of opposite sides. Make sure we're saying both because it can't just be one. Both pairs of opposite sides are congruent, therefore this is a parallelogram. Sandeep, you want the last one?
Yeah. Show that one pair of opposite sides are congruent and parallel.
Okay, so first of all, they said that BC is parallel to AD and BC is congruent to AD, so it looks like that. And I'm sorry, which one did you say that was?
Number 4, show one pair of opposite sides are congruent and parallel.
Good. One set of sides are both congruent and parallel. All right, that's all we've got today. That is 8.3. It's a short lesson. There's 5 rules, but you need to know those because you're going to be asked to identify why is this a parallelogram. And once you know, like, if it's a parallelogram, and sometimes it's not as obvious that. Sometimes you have to work to them. Sometimes instead of having lines there, it might have numbers there. So sometimes you might actually have to do some calculations to figure out what things are and then see what it matches.